All right, guys, welcome to another episode of Cuda Education. Uh, Today, I want to talk about semaphores, right? So are in our synchronization hell series. This is going to be video number 2 that we are talking about breaking semaphores, right? So let me just run the application so you see what we're talking about. We have a cloth, canvas, or whatever you want to call it, that is going around a ball, a sphere, and it's falling onto the sphere, right? That is basically what we're dealing with, right? Nothing, I mean, it's a lot going on, but nothing too special, right? We could also simulate wind. So if we simulate the wind, we see that the cloth is now moving because we have wind being simulated. If we turn off the wind, everything just kind of lays flat on the sphere, okay? So, we want to go through exactly what is going on behind the scenes. Okay, so let's just cue into a very specific part of the script that deals with the compute and the graphics commands, right? So certainly there are two things going on. You have to compute the canvas hitting the sphere, compute how the canvas changes as it hits the sphere, all the wrinkles, all the striations, all of that stuff, right? All of that stuff is mathematics, right? Even the wind is mathematics, right? So we have to compute stuff and then we have to display stuff, right? The thing with Right, so there's compute stuff and graphic stuff. So we have to we have to we have to have some separation between the two, right? You 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 compute stuff first and then you draw the actual graphics, right? So before you actually before you actually see this stuff being displayed on the screen, it has to be calculated, right? It has to be computed, right? So you compute stuff and then you draw the frames that actually go to the screen that we see 1463 frames per second or what have you, right? So you compute stuff, you draw the frame, and then you display to the screen. Now notice that I said compute, draw stuff, and then display to the screen. We actually have two semaphores here going on. We have one semaphore between the compute and the graphics, and we also have another semaphore between the graphics drawing the frame. So you have a frame and it's like a portrait, and you're painting on the portrait, you're painting on the canvas, on the art canvas, and then you display it to the screen. So displaying it to the screen means displaying it to your 4K computer monitor or whatever it is you got going on. I don't know what the latest computer monitor technology is, right? But you're displaying stuff to the monitor, you're displaying stuff to the screen, you're presenting stuff, right? So we have to have a semaphore between compute and graphics, and we also have to have, well, so compute and graphics, and then back to compute, and then back to graphics and all that. So there's a compute and a graphics piece of it. And then we also have to have a semaphore for graphics to presenting to the screen. Okay, so we draw the canvas, we draw the picture, and then now we have to send it to the monitor, to your computer screen. And that's what the second set of semaphores are. So you notice you have present complete semaphore, render complete semaphore, right? So these are semaphores associated with managing frames that you either are allowed to draw on them because they're not being presented, or you're not allowed to draw on them because they are actively being presented, right? So we have compute, graphics, and then presentation. Okay. So we have semaphores that deal with the computer and graphics stuff, and then we have semaphores that deal with graphics, which is drawing and then presenting to the screen, which is you're presenting to the screen. This is a swap chain conversation. If you want to dive into that piece of it, the presentation and the swap chain stuff, I have a whiteboard on my channel that talks specifically about that, about the swap chain. I draw out the swap chain. I draw out, you know, removing and a swap chain is just a, all it is just a queue of frames. It's a queue of canvases, a queue of frames, right? And you could remove a blank canvas from the swap chain, draw stuff on the canvas, and then put the canvas back into the swap chain. Towards the end of the swap chain, the final piece of the swap chain is that all these queued up frames eventually go to the presentation. So they basically go to presenting to the screen. There's another way you could look at it. Let's say you're at a puppet show, right? There is the puppet that is above the, on the stage, and the puppet is being presented, right? And then there's someone behind that obviously is moving the puppet and stuff. But um so you kind of have but then you could remove the puppet from the stage. You could basically drop the puppet below where the stage is, and then you no longer see the puppet, right? It's a similar thing with this with the drawing and the presentation. So you remove canvases, blank canvases from the swap chain, you draw stuff on it, you put it back into the swap chain, and you clear it for presentation to the screen. But remember, you cannot be presenting something to the screen while you're drawing on it, right? That is why the semaphore is there, so that you don't draw on stuff that you're presenting to this, that is being actively presented to the screen, and you don't try to present stuff that's actively being drawn on. So a frame that is actively being drawn on, you don't try and present to the screen, right? So you got to manage that relationship. All right, so we have compute stuff, we have graphic stuff, and then we have presentation to the screen. Also notice that there's a loop. So there's compute stuff, there's graphic stuff, there's also the presentation stuff that's like, behind the scenes too, but then we loop back into compute and graphics again, and we'll discuss that in a second, okay? So what is a semaphore? You guys probably asking, what is a semaphore? A semaphore is synchronization between two processes on the GPU. So you have process number one and you have process number two. These two processes run on the GPU. The thing though is that you want to make sure that before you attempt to do process number two, that process number one is finished and complete, and it does not have ownership over the thing, is not actively trying to do stuff on the thing, nothing like that, right? So in our case, we're talking about, compute processing and drawing stuff, right? So process one, process two, you have two processes on the GPU. Semaphores are GPU synchronization. Two processes on the GPU. GPU synchronization. You put a rule in that while process one is happening, you can't do process two. There's also a rule while process two is happening, you can't do process one, right? And you kind of loop between the two, and that's what a semaphore is, right? So you have compute stuff, and then you have graphic stuff, and then you also have presentation stuff. The GPU is the one that's actually presenting to the screen, and that's why we have present semaphore, present complete semaphore, and render complete semaphore, So all GPU stuff we're dealing with right here, right? So and the general process is we compute stuff. Once we finish compute, we draw stuff. Once we finish drawing stuff, we do present to the screen, but let's just put that to the side for now. And then we loop back to compute, because the reason why we loop back is because we have to compute the next frame. We have to compute what is the next thing that we want to show, But in order to know what the next thing we want to show, we have to compute it first. So we compute the thing, and then we go to graphics and we actually draw the thing that we compute, and then we present to the screen and blah, blah, blah. So it's like a loop, okay? So we're dealing with a loop. All right. So for the compute stuff, we have a wait semaphore and we have a signal semaphore. The wait semaphore generally is the thing that you're waiting on. What are you waiting on? Okay. So for the compute stuff, what we're waiting on is compute semaphores ready. So we're waiting for the ready flag on the compute semaphore, right? So we're waiting. See, you notice that we have wait semaphore. Wait semaphore count is 1. We're waiting for the ready flag, okay? We're waiting for the ready flag. Compute semaphore is ready. Don't worry about this for now. This is like the index that we're pointing to. We're waiting for the ready flag, okay? Once we're finished, once we got the ready flag and we have clearance to proceed, then we actually proceed. And we do what we need to do in compute. And then there's another flag. So we have a signal semaphore, right? And a signal semaphore basically is saying, okay, what flag do we show once we tell the world that we have completed our process? Compute semaphore is complete. Okay, so the signal now is compute semaphore is complete. What does that mean? It means that we have completed the task at hand, and any other processes that want to take over from now can do so. It has clearance, okay? So we have a wait semaphore, what we're waiting on, and we have a complete, we have a signal semaphore that's saying upon completion of our process, we have a complete flag, right? If we now proceed to the graphics side, we're going to see there's going to be a switcheroo, right? Which makes sense because once we signal that the compute is complete, right? Compute semaphore complete. What does the graphics do? The graphics is waiting on the complete from the compute stuff, right? I know this is a tongue twister. Stay focused, pay attention. The compute stuff signals that it's complete with the signal semaphore, right? Compute semaphore is complete. The graphics semaphore now waits on that signal. So notice that they match, right? Complete, complete. So we're matching. We signal that we're complete here, and the graphics commands is wait semaphore is waiting for that signal. Once it's gotten that signal, then the graphics can proceed with its set of commands, right? When it's done with its set of commands, again, we have signal semaphores. And what is the flag that the graphics commands raises when it's done with its stuff? It switches compute semaphores back to ready. Okay? We have seen this before. Compute semaphores ready. We have seen this before because when we go back to compute, we see that what does compute wait on? It waits on ready. See? So you notice this is a string, the chain that connects one to another. So compute waits on ready. It signals when it's complete by saying complete. Graphics waits on complete, and then when graphics is done, it signals and it says ready. When it signals and says ready, then compute can proceed again because compute is waiting on ready. Okay? And that's just basically the flow of how this goes. What in each step, what we're trying to do is actually this VKQ submit. So we're submitting commands. We're submitting commands to the queue, and we just have to make sure that the background stuff that we're dealing with, everything is kosher and done correctly and according to spec. So by the time this is ready to submit, or has been submitted, we have our complete signal, and then the graphic stuff can do its thing. Notice that there's a VKQ submit here for graphics also. Okay, so that's the semaphore stuff between graphic compute and graphics, right? We have a VKQ submit, okay. All right, so we're submitting commands to the queue, but when we're doing that, we have to make sure that everything. Notice all this submit info is included in the VKQ submit command, anytime we see a lowercase vk in Vulkan, we know that it's serious stuff we're dealing with, right? So all of this work is being done so that we could do vkq submit, and notice that all of this information is being encapsulated in submit info, right? So we have it here and we have it here, right? So that is the compute and graphics semaphore relationship. There's also the issue of presentation and rendering. So for graphics, the graphics commands, remember now, we're drawing stuff, right? So in order to draw stuff, we have to wait and make sure that presentation is complete. Okay? So we're wait semaphore. We're talking about the drawing stuff now. Before we can draw stuff, we have to make sure that the presentation is complete. We have to make sure that the presentation is we're not actively presenting, right? So once we have clearance that we're not actively presenting, then we could draw. Once we draw, so what does that mean? That means we're taking a canvas out of the swap chain clue. We may or may not be clearing it. Clearing it just means making it blank, because there might be stuff on the frame from the previous. There might be stuff on the frame from the previous situation, whatever. We clear it and then we draw stuff, right? So once we have clearance that this frame is no longer being presented, we have clearance to draw stuff on it, okay? Once we draw stuff and we're finished drawing stuff, we have a signal semaphore. What is a signal semaphore? The signal semaphore is render complete semaphores, okay? Render complete semaphores. Render complete, that basically means that we have done drawing on this frame. We've done drawing on this canvas, we've done drawing on this portrait, and now since we're done drawing, the world can do whatever it needs to do with it. We're done drawing on this frame, on this canvas, whatever you mean, right? So it's the same thing. You wait on presentation to be complete, and then once you finish drawing on the canvas or on the frame, you signal that render complete semaphores, right? Notice that all of this is inside of the render function, right? Which, we'll fight that battle another time, but this is inside of the render function, right? And that's pretty much it. So if when we run our application, we basically see that everything is everything. It runs fine, okay? Now I also run this stuff inside of Vulkan configurator. Vulkan configurator, you get it in tutorial number 1. So in tutorial number 1, under the Vulkan folder, wherever you install Vulkan, there's a vk config file that basically, after you've gone through the tutorial of tutorial number 1, there's a vk config file that has the Vulkan configurator. In there, you're able to run the validation layer and see like all the messages from the validation. This is a conversation between NVIDIA and Vulkan. It has nothing to do with me or Cuda Education, so don't worry about this, right? But we see that here, when I launch inside of the Vulkan configurator, my application still runs, and I don't have any errors or anything. Now, what we want to do is mess around with the wait and signal semaphores, right? So instead of doing things correctly, we're gonna start to mess around with the semaphores, right? So instead of it being ready, we're gonna say this is complete, which is gonna confuse everything because it just doesn't make sense, right? It just doesn't make sense. I mean, I'm not gonna go through the line of logic, but basically it just doesn't make the relationship between the two just doesn't make sense, right? So I'm gonna have to rebuild the file so that the Vulkan configurator can run, and we could see what the validation layer tells us, right? So when we basically now we're waiting for a complete flag, but yeah, It just is. It's not. It doesn't work, right? So the application still runs. That's one of the difficult things I had, is that the application still runs. It runs just as before, okay? But what you're gonna see is that now we have errors, right? And the errors basically say from the very top, error wait semaphore is waiting on semaphore, blah blah, that has no way to be signaled, right? And it basically gives, it's repeating the same thing, has no way to be signaled, has no way to be signaled. Is already waiting on semaphore, is already waiting on semaphore. Well, you know, but basically it's saying that like something isn't right, right? We're not gonna go through, you know, I'm not gonna get into detail, but basically things aren't lining up, right? Um, you know, and you know, I could change all of this stuff, and you basically will get the same, you know, similar errors, right? But I mean, I don't really want to, I don't really want to do that. I mean, you could do it on your own time, but basically you're gonna get a bunch of errors if if we if we don't you know, if we don't have things lining up properly, right? Um, so let's put things back to the way they were, and just make sure that we're back to baseline. What I want to do, and actually I haven't done this, but I want to remove the presentation semaphores, the presentation and draw, you know, swap chain stuff. I want to remove these semaphores and see what happens, see what errors we get, right? Um, I was more interested in these flags. All right, so we've built. Okay, so we're back to, we still get our application, and we're back to a clean set of circumstances. Okay, so let us mess around with the let us mess around with the swap chain and presentation stuff, right? So now let's rebuild the thing. We have removed the presentation and render complete semaphores. Presentation complete semaphores and render complete semaphores. I'm curious to see, what does the Vulkan validation layer say when we no longer respect the fact that you know, when we're presenting frames on the screen on the computer monitor, that we can't be drawing on it also, right? So let's run it and see. Okay, well, first of all, I don't even get you can't see it because actually the application crashes. So let me at least try to yeah, the application crashes. Um, okay, so when I so when I run it, I get validation error, invalid semaphore objects. Um, let me see if I'm. Is it a programmatic thing, or is it a? Or it might be. Okay, hold on. Oh no, I have to change this also. Okay, let's do this again. Maybe that wasn't. Um, so I'm trying to just remove the semaphores related to presentation and the swap chain stuff, right? Because I want to see. I want to see what happens. Okay, so we still get our application running, but then now we get this stuff. What do we get? We get, yeah, we basically get the similar thing, but we notice that it's now VK acquire next image KHR. Semaphore will not must not be currently signaled. You know, we get a different set of circumstances, right? Is that, yeah, well, I don't want to go out on a limb with this stuff, but let's just get back to normal. And but you guys get the drift though. Is that the acquire next image and all of that stuff is the acquire next image and all of that stuff is the VK acquire next image KHR. That's all like swap chain stuff, right? Because like you're trying to acquire images out of the swap chain and all of that, right? So notice that the error sort of changes. But let's go back to baseline. Let's go back to baseline and just make sure that we're back to what we expect, right? But you guys get the idea though that like um, you know, there's also the presentation piece of it, presenting to the monitor and having the swap chain, you know, taking stuff out of the swap chain, drawing on the frame, putting stuff back into the swap chain, and then presenting to the screen. I have a whiteboard on that if you guys want to dive into it some more. All right, we're basically back to what we normally expect, right? Okay. All right. So the next thing that we want to do, we want to further break. We want to go back to the graphics. I mean, the compute and the graphics relationship, right? So we want to break. We want to break these semaphores, right? We want to break the semaphore. So, what we're gonna do on the graphics side, what we're gonna do is we're gonna do away with. Um, we're gonna do away with the semaphore flags on the graphics side. Okay, so we're gonna remove these semaphores on the graphics side. So we're not, the graphics is no longer waiting for compute to complete, and the graphics is what are we doing? Right, the graphics is no longer waiting for the compute to complete, right? So let us just break this piece of the equation, right? And of course, we this semaphore, right, is associated with the vertex buffer, right? So it's a vertex stage. Basically, when we're talking about drawing, we're talking about the vertex buffer and all that stuff, right? So what we're gonna do is we're gonna remove this semaphore here. Well, graphics is no longer gonna wait for um, it's no longer gonna wait for compute to be done. We'll leave everything else the same, but it's no longer gonna wait for compute to be done. So the wait semaphore is just now 1 because we're just you know we're still dealing with the presentation and swap chain stuff, but we're gonna neglect we're gonna neglect drawing waiting for it to be done, right? So when we do that we should see an error pop up, right? And this makes sense because basically graphics is just going to start drawing stuff. Okay? And it's not going to wait for compute to be done. All right? So we have, it still displays, which, you know, I don't like the fact that it still runs, right? But when we look at our thing, it now has, it's being signaled by VKQ, but was previously signaled by VKQ and has not since been waited on, right? So basically, it's saying that we're not waiting on anything. Has been signaled by, but it's previously not been. So, you know, like, I guess it's saying compute signal stuff, right? But graphics, you know, it did not wait on the signal. It just kind of did its own thing, right? Now the thing is that the application still runs, which I don't like the fact that the application still runs, but you know, you get the drift, right? You guys get the drift. Okay. So you know, that is our synchronization hell lesson for today. So let's make sure we get back to baseline. So wait signal count is 2. The wait semaphore count is 2, I'm sorry. And we also have to put back the stage stuff. So we have our complete stuff, and we have our you know, the vertex input stage or vertex buffer stage, whatever, right? So let's just put things back to the way they were, and then we should you know, we should be good to go. Okay, so we're back to where it was, right? The validation layer doesn't show anything crazy. And then we're back to where we were. Okay, so that's it for this this video. Next video I'm gonna talk about, I'm gonna start tinkering with the fences stuff. But this is Synchronization Hell, guys. This is the video 2 of the Synchronization Hell series. I call it Synchronization Hell for a reason. But you know, it is what it is. We're learning computer graphics. We're learning Vulkan. This is a long-term process. So start on the train ASAP and build your knowledge as you go. This is going to be the second video. Again, guys, if you want to join in on the fun, I assume you have a Windows-based machine with a Vulkan-capable GPU. Right? Tutorial number 1 installs the Vulkan API. Tutorial number 13 installs all of these examples. Now, if you want to run the ray tracing stuff, you also have to make sure your GPU is ray tracing capable. That's the RTX series and later for NVIDIA. I don't know about the other vendors. All right. Thank you guys for watching. Have a great day.